Hello everyone, welcome to this discussion. In this particular video, we are going to discuss AASL number 2022, paper 2 and question number 7. It's a calculus based question. It's particularly differential calculus and integral calculus involved here. So let's get started. Okay, in this question, a particle moves in a straight line. Its displacement s meters from a fixed point P at time t seconds is given by a function. So s is a displacement function, and particularly from a fixed point P, how it got the displacement is function modeled in this way. And for the time between 0 to 6.8. And the graph is shown here. Okay, so this is what 0 to 6.8 is how it is. Fine, and then we have to solve around 5 questions of this. Let's do first. Find the particle's initial displacement from the fixed point P. Initially, how much displacement is there? That's what. And displacement function I have, it depends on T, and initial means its T is 0, right? This is the initial condition. So directly we can substitute. Also graphically we can solve. So while substituting, let's do first. So method 1, substitution. S of 0, 3 times T means is here 0, plus 2 and power cos 0. Some of you might forget cos 0 is 1, but you should memorize it. So 2 power cos 0 is 1, 3 times 2 is 6, and easy, 6 meters, right? So the displacement function is given in meters and time is in seconds. So T. So method 2, graphically. So graphically what we're going to do, here with this graph we can't do. There is no much details here, but using GDC we can do. So graph the function and check the value like when x is 0. Like in y-axis, the y-intercept will be your answer. So let's get into the graphical calculator and solve this. Here is the GDC for you. Okay, so here is a graphing calculator. Let's draw a graph and figure it out. Right, so what is my function? 3 times x plus 1, x plus 2 actually, x plus 2 raised to the power cos x. Actually, there is t given, but here we can just go with x. Make sure we are interpreting it in correct way. This is the function. Actually, we want the first quadrant alone. So let's get zoom into that part. Right? And also I'm solving for 1 to 0 to 6.8. Okay, first our aim is initial displacement, how we can solve with the graph. And this graph is drawn and the y-intercept is what we need to figure out. So go for the menu. Y-intercept, there is no. So we can just go for graph entry and go for equation templates, line, vertical line. Because y-axis is a vertical line and it is x is equal to 0. You give it. 2 graphs have been drawn and the intersection is our initial displacement. Like when t is 0, what is yes? This graph is yes. So click graph 1 and click this. Let's find the intersection. Intersection is around this. So let's make, yeah. So it's clearly 0, 6, but sometimes very minute values. So let's go with this. And here we go. Okay. And this is the intersection of y-axis and the graph, and that is what we need, right? So let's get into the solution page now. Graphically also we can solve. Here we go. So it's 6 meters, right? And next part, find particle's velocity when t is 2. Okay, so this directly, we can't differentiate it actually. Displacement, what's the concept? Velocity is differentiation, the first derivative of the displacement function. So we need to find s dash of t, but it's quite complicated, right? S of t is 3 times t plus 2 whole power cos t. So yeah, we can directly go for graphing part. Yeah, using GDC or using numerical solve, both will work here. So let's do one by one. And we are switching into the calculator again. Here we go. Okay, using calculator, we want derivative at a point, right? So go for this and calculus, numerical derivative at a point, this will be suitable. So go to it, and our variable is actually t, but we are solving, let it be x here. And at which point we are solving? When t is 2, that is x is 2. We need first derivative, so let it be as it is, and click OK. And d by dx of whatever function we have to. And make sure you're using the x here. It's 3 times. Then open the bracket and include the function. The t x plus 2 whole power cos x, right? That's it. And it's very simple. We can solve it quickly. Here we go. Okay, everything is given perfectly and click enter. This is my velocity at particularly at x is equal to 2. Negative 2.29921. That's an approximate value, right? And let's switch to the solution page. Here we go. So s dash of t, or we can call the s dash of t, it's v of t also, right? So this, when velocity, when t is equal to 2 is this. S dash of t at t is equal to 2, or we can say v of t at t is equal to 2. Anyways, we got the answer is negative 2.29, which is negative 9921. When you try to approximate, it's going to be negative 2.23, just 3, right? And what is the unit for it? Velocity, it's meter per second, right? And that simple it is. Meter per second. Now, next part, determine the intervals of time when particle move away from the point P. Actually, our function is modeled in such a way, displacement with respect to the point P. Now, at which time interval the particle is moving away from the point P? So, which differential calculus concept will apply here means when your velocity is greater than 0, that is positive, the particle will move away from the fixed point. When your velocity is negative, it's coming closer to that point, right? Okay, so now we need, so to solve this, again, velocity we depends upon, but velocity function is quite difficult to find. So we can go with graphing calculator. Okay, the aim is finding velocity greater than 0. At which intervals? That's simple. So in graphing calculator part, we're going to graph the derivative function. And then we will look for where it is positive. Here we go. Let's switch to the graph. Okay, so we need a function. S of t is known, but we need velocity. So go for this. First derivative is velocity. So d by dx, and whatever the function, 3 times x plus 2 whole raised to the power cos x, right? And okay, can you see the difference? The previous one was s of t, the displacement function, and now we have graphed the velocity function, correct? Now, what is our aim? When velocity is positive, it will move away from the point P. When if it's negative, it will move close. So positive means very simple, above the x-axis, negative below the x-axis. So above the x-axis, again a problem that is, we can't see the exact values over here, but we want to represent the answer in the interval notation, right? Okay, so let's go with this. Let me zoom this to the quadrant 1. And we are solving for from 0 to 6.8. That we should keep in mind. Okay, I can see, okay, 0 to this intersection point, I can see that, okay, the graph is above x-axis. But 0 to what? That's the question here. This point I need. It is very simple. This particular graph, x-intercept we need to find. So find this point, also this point, maybe this point also. Let's check whether all 4 holds good. But still 6.8, all the x-intercept we're going to find, right? And then we will solve, but let's go with this first. So we need to find the x-intercept. And here we go. Menu, analyze graph. X-intercept means 0, but here we need to do one thing. Every point we have to make, like from here to here, you got 0.433. Then for the next part, so set your upper bound and lower bound. Go for 0 again. This around this I need, right? So here to here, upper bound and lower bound, around that point you have to go. So second intercept also, x-intercept, so I got. But what about the third? If it's close, if it's less than or equal to 6.8, it's accepted, but otherwise it's not. Go for analyze graph again and 0. Around this is the intersection we are looking for. It's 6.34, yeah, it's still acceptable. Okay, so now 0.433 and this is 3.26 and this is 6.34. Right? What we are looking for, at which interval the graph is above x-axis. From 0 to this intersection, it's above x-axis. So this is the interval I'm looking for. But next is below 0. That is 0.433 to 3.26. It's below 0. So we are not going to take that. But after that, it's completely above x-axis. From which to which 3.26 is 6.434. Wait. Actually, we are solving for still 6.8 or 6.28. Yeah, we are solving for 6.8. So this is acceptable. So my answer is this interval and this interval. Okay. So let's take this and represent our answer in the interval form. So see how the GDC help us here. Let's switch to the solution page now. Here we go. Okay, so let me plot the graph here. And for this particular question, the interval is going to be 0 to, and it's t, right? 0 less than or equal to t, less than 4.33, because I don't know whether it's closer value, like an approximate answer, right? And also 3.26. Let me better write it here. 3.26 less than t less than 6.34. For these intervals of time, the particle will move away from the fixed point P. See, that's simple. And we are moving into the next part. Now, this is a description. Acceleration of the particle is 0 when t is b and t is c, where b less than c. Find b and c. And one more question is, find the total distance traveled by the particle in this particular interval. Let's find B and C. What is acceleration? When you differentiate the displacement function twice, we got acceleration. S double dash of t, or we can say V dash of t. Velocity, again you differentiate. Okay, it's 0. So what is our aim? Draw the double differentiation, second derivative of the function, and find it 0. Where the particle is 0 means you have to find the intercept. And then those are the t values. After finding that, yeah, that's simple. If you find that is your B and C and B less than C. So let's see. Let's switch into the graphical part again. Here we go. This is actually already graph 1. We are not gonna use it. Let's add a new graph, which is Second differentiation, acceleration is second differentiation, and here we go. D square, this box we can see, right? So go for this format, and we are differentiating with respect to x, which function? The displacement. So 3 times x plus 2 raised to the power cos x, wait, cos x. Okay, so that's it, and click enter. This is the acceleration function, and of course we are focusing on first quadrant from 0 to 6.8, right? So let me take, where is first quadrant? Yeah, here. Okay, and here we go. Okay, what is our aim? Acceleration is 0 at B and C. What is B and C? Okay, so what are the x-intercept? I can see an intercept here, and after this, let's go. This is not needed. Let me get rid of that. Right. So this intercept I need to find, then this, but still 6.8 we can find. And go to the menu, analyze graph. 0 is nothing but x-interception, right? So here to here, 1.23. And next intercept I can see, go to analyze graph, 0, and click on your lower bound, that is left of the whichever we are suspecting. Actually, it's quite clear. And 5.69, yeah, it's accepted. Okay, next also I can see, but let's see. Menu, analyze graph, 0. Around this, it's 6.99. So this is not accepted, right? Why? We are solving. Our domain is still 6.8 only, so we can ignore it. So I'm going to take only this particular part. Right? And let's go. This is my BNC, 1.23, and this is the 5.69. I have moved it. Right. So let's go. Simple. Actually, we are not at all doing anything algebraically. Just the concept is to be clear here. And here we go. So my B is less than C. So you choose B as 1.23 approximately, and C is 5.69. Right. That's simple. Now next problem. Find the total distance traveled by the particle B less than or equal to T less than or equal to C. We have a formula in our that is formula booklet, that is distance traveled and displacement, total displacement for all this. Let me show you the formula booklet. Here, acceleration, so this also you can use. Distance traveled from two particular points is T1 to T2 integral and modulus of V of T dt. Okay. Then displacement from T1 to T2 means it's just T1 to T2 V of T dt. That's the difference. So we have to use this formula. Right? This is our case. Right? And we can go with that. Again, we're gonna do it graphically. That will be much simpler. Here is a solution which. So, and I know what is B and C also, correct? Here, find the total distance traveled by the particle, and it is total distance traveled by the particle, let it be D. It is integral. B is 1.23 and is 5.69. Modulus of V of T dt. So what happened in the modulus function? So integral 1.23 to 5.69. So it will be break into two parts, negative and positive. So negative V of t and positive V of t, and the interval will get breaked. So let's see how to do it. So directly we can go with this stuff, graphical part. We will graph and then we can just find the displacement, total area under the curve and above the curve. That's the thing. Let's get into this. Okay, actually we need V of t. So let's, V of t, is it already marked? Check. Okay, so we can take a new one. What is V of t? D by dx of our displacement. So let's quickly do that. D by dx of, what is the displacement? It is 3. We are using it a lot. X plus 2 raised to the power cos x. This is V of x, and we are looking for first quadrant. Integral 1.23 to 5.69, which means the bounded area. So let me plot 1.23. X is equal to 1.23, means it is going to be a equation, a line, and a vertical line. X is equal to a constant. So X is equal to 1.23, and one more is 5.69. Till that, I need to find the displacement, that is distance traveled, sorry. X is equal to 5.69. And here we can see the blue line, red line. This X is 1.23 and this 5.69. So the distance traveled by is the area bounded by these line and the graph, correct? So we want to find these. Area under this. That's why modulus we are using. Okay, exactly to the red. So it will be go on and on. So this is what we are focusing. Right. And how to find this? So go for the menu and analyze graph. We have the bounded area. And it is asking for a graph. The main graph is this. Second graph, choose the x-axis. It's bounded by x-axis, right? X-axis. And lower bound, it's 1.23. And upper bound is this. See, the exact portion is shaded here. And the calculated value is displayed here. It's 19.6. So that's the thing we have to do. It's 19.6. Integral way, we can say it's a bounded area, but actually our answer is the total distance covered in this particular interval. Got it? So let's take this. And let's switch to the solution part. So the displacement, sorry, the distance covered in this particular interval is 19.6 meters. Distance traveled. That is 1.23 less than or equal B less than or equal 5.69 equal 19.6 meters. This completes the solution of the problem. And that's it. We can meet in the next interesting video. And thank you so much for listening.